Hello, welcome to our webinar, Water Handling Equipment Safety and Sanitation Testing. Thank you for joining us today. This webinar is being jointly given by MET Laboratories and NSF International. MET is a leader in the testing of electrical and electronic equipment for environmental hardiness, product safety, and electromagnetic compatibility. MET operates world-class labs in Baltimore, Maryland, Santa Clara and Union City, California, Austin, Texas, and also runs operations in China, Taiwan, Korea, and Italy. NSF International is an independent, not-for-profit organization that provides standards development, product certification, auditing, education, and risk management for public health and the environment. The NSF Water Division certifies products that come into contact with drinking water, such as plumbing components, water treatment chemicals, and drinking water filters, as well as pool and spa equipment. This webinar will run about 45 minutes, with an additional 15 minutes allotted for questions and answers. Due to the number of registrants, all attendees will have their phones muted. If you have a question, please type it in the questions area of your control panel. We will attempt to answer all questions at the end. If you're having technical difficulties, you can contact us the same way, or if that doesn't work, call us at 410-935-6053. That's 410-935-6053, and we will try to resolve any problems quickly. Just a quick note on another upcoming event. Later this month, MET is hosting a free overview webinar on product safety certification using the CB scheme. You can register for this event at www.metlabs.com. Today's webinar is being presented by Rich Martin, Lauren Foster, and Rick Cooper. Rich is the Business Development Manager of the Recreational Water Program at NSF International. Lauren Foster is a Safety Engineer at MET Laboratories. And Rick Cooper is the Safety Laboratory Director at MET. At this point, I will hand over the presentation to Rich.
Thank you very much, Barnaby. As Barnaby mentioned, my name is Rich Martin with NSF. I serve as the Business Development Manager for our Recreational Water Program. So thank you all to attending today's webinar. Next, please. Today's agenda is just going to cover a little background about NSF, because we always have people on these calls that aren't familiar with the organization, so it's just a good foundation or background to go over. Then we'll also talk about codes and standards, just to provide the perspective of how those two issues are different, but how they're also interrelated. And then get into the issue of why the codes and standards both matter to you. And then drilling down more into the details of program services for recreational water program, and then the specific standards that are used or referenced. We'll also cover some of the product types that are covered in the certification program, give a little bit of an overview on the certification process, and then also some examples of product evaluation and testing criteria. And then toward the end of the presentation, just give a quick walkthrough of finding listed products for this pool and spa industry and how to use the search engine, concluded by the summary as well as just some contact details for you. Next, please. So NSF has been around for a while. The company was formed in 1944 as an output from the University of Michigan School of Public Health. What happened was there's just a number of graduates that were finding problems and difficulty in the marketplace where restaurants were having problems with the equipment they were using. The manufacturers were saying that they were designing the equipment to meet, the requirements of the public health officials in a certain state or a certain city, but then those requirements were different from other cities. So there's this lack of consistency in what the requirements were. And so the NSF was formed by the University of Michigan School of Public Health to really try to help work through those issues, resolve them, and find commonality in standards development for the food industry, and then it evolved from there. But today we're known as NSF International, and we have operations in over 28 countries. Next, please. Just as a little bit more background, NSF has about 80 different consensus standards currently, and part of our history is, of course, working with different governmental organizations. NSF is a non-governmental organization. It is a private foundation, but we're also collaborating center with the World Health Organization, so we've been active in areas of food and water safety for many years. We have basically companies or clients that we work with in a number of countries, and then most of the work that we do is involved in food and water safety and incorporating different aspects of either chemistry, engineering, microbiological, sustainability, or energy assessments. Next, please. This little timeline just gives a visual, and if you look on the far left side, really the second circle there, 50s and 60s, you can kind of see where we originally were, founded and the work that was first being done in the food service and food safety areas. The test lab was opened, evaluating different swimming pool equipment, and then plastics, plumbing. And then in the 70s, 80s, it kind of gets into the drinking water areas. Then after that, in the 90s, things start to change, and it wasn't just this kind of organic growth. NSF started to collaborate and work with form joint ventures or actually acquire companies like QAI or others that do organic certification and things of that nature that relate to the food industry. Doing other things as it relates to verification of food chains and then food safety, food auditing, outside, let's say, the water industry. So again, typically you'll see NSF interacting in these food and water industry workplaces in one way, shape, or another. Next, please. This is just a little overview of some of the different offices for NSF. Some of these are labs, but most of them are personnel offices to be close to our clients. Next, please. Next, the page here is really about accreditations. Anyone who's providing service, technical services, has to have some level of corroboration of their skills or competencies, and that's evidenced by, in this case, NSF's function as a standards writer being approved and accredited by American National Standards Institute. Also, American National Standards Institute and Standards Council of Canada accredit the NSF certification programs. And then the lower section just shows that, yes, our labs are tested and, if you will, audited and accredited by the EPA, IAS, OSHA, Standards Council of Canada. And that's all as part of the ISO 17025 lab accreditations and verifications. So companies such as NSF and many others, of course, are audited in accordance with ISO 17025 for a long list of different standards, whether it's ASTM, ASME, or other standards. Next, please. As I mentioned a bit earlier, NSF's been working with different entities. Sometimes it's in a real collaborative fashion. Sometimes it's I don't know, kind of more like an expert reference or guidance on certain guidelines that other entities are creating. But we also get that same type of input back to help us in our development of our programs and our standards. So we collaborate with others to help on their projects and vice versa. In the areas that we interact with the World Health Organization, that's, again, typically on this drinking water, recreational water, or food safety, also indoor air and environmental issues. But then with some of the more North American companies and entities that are truly governmental organizations like the Center for Disease Control and Prevention, and then the EPA and others, those ties are really to help make sure we're doing the right thing as far as setting up our standards to address existing infrastructure and requirements or guidelines and laws, but then also developing upon that foundation and dialing in other requirements. Next, please. So just giving a little bit of background on NSF, and the next thing we'll do is kind of launch into this concept of standards and codes. Well, you see here we're talking about the model codes, the city, state, county codes, and at the end I kind of say that they're under construction. Well, Not the kind of thing you want to see when you're driving down the road and you're going to hit some traffic, but the same sort of dynamic applies with code development. Next slide, please. With the North American market, there's actually a little graphic like this on the NSF website, and you can go to it and click on each state, and it'll take you to the state code as it relates to pool, spa, operational aspects, and safety. So state codes or city county codes, those are the two kind of oldest requirement sets that you'll see. You know, some state codes go back to the 1920s, but of course they've been updated and modified a number of times. But in a particular case in point, California code, T24 if you will, that's their design operational code for pools and spas, sort of like the state regulation. That had not been fully revised since the 1980s, but it was just revised in late 2012. So you can see that kind of lag time that can occur with state codes, and sometimes it's a funding issue, it's a political issue, but then you also see this reference below in the kind of middle part of the slide here about 3 model codes. Well, there's different code groups like IAPMO and ICC that are traditionally known as writing plumbing and construction codes. Well, they've gotten into it and decided to write some model language or codes to help, you know, dovetail in with their code initiatives for construction or plumbing, venting, and other heating type code language. And then the last one I referenced here is the CDC Model Aquatic Health Code. That's still a draft, but that's another code being developed by another entity. And then at the very bottom, it just mentioned some of the World Health Organization guidelines. So these are all good resources for anyone who's trying to learn more about what is required where. Next slide, please. This is just a little bit of a dive into the first of those 3 model codes that I mentioned, the ICC code. So in this case, the International Code Council contracted with the Trade Association for Pool and Spa Industry, the APSP, and really kind of took some of these existing construction standards from the Trade Association and then rolled those up into be more of a construction code. So not so much of an operational code, you know, not telling you really how to run your pool or spa or maintain it, but just giving some guidance on how to do the design, the build, the construction, what kind of equipment is required. So this code just came out last year. If you could, next slide, please. You'll see in this code and then some of the others a bunch of references to certain standards. And typically, they'll reference NSF Standard 50 or Standard 14 or Standard 61. So those are kind of 3 NSF standards that are relevant in this space of pool and spa recreational water safety. Specifically, Standard 14 relates to the piping and the fittings and some of the plastic components. Standard 50 is like a broad umbrella standard to address pool and spa type equipment. And then Standard 61 addresses just drinking water products. Next slide, please. Next code was that IAPMO code, the Uniform Swimming Pool, Spa, and Hot Tub Code. It's very similar in goal and intent, but it definitely has a different twist to it, and you'll see that on the next slide. But again, this code has been around the longest as far as a model code, but it probably didn't really have that much uptake yet. And I think I've got an idea of why. It seems to be really heavily focused on heaters, vent gas, safety, and piping, but it seems a little light in some other areas. So, you know, I can't say that there's any one code that's perfect, but some codes might be really good at certain things and then just not have a lot of detail in other areas. But again, this code was designed to help dovetail with their plumbing code. Next slide, please. Here's, you know, again, quick references. You can kind of see this recurring theme of reference to the Standard 50 in the code. So you've got the code, and that's kind of telling you from what the building inspector will require, what will be required when the inspector goes out to visit a facility that's under construction or after construction, or even at the, let's say, the beginning part, design submittal, you know, submitting drawings and things. But then you kind of see under the scope and content, there's more of an assessment of what types of requirements and how much detail do you have. Well, Chapter 6 has 3/4 of one page about the equipment. Water quality was only 4 pages, but it was, again, it was super, super detailed on water heating and venting and fuel gas piping. So it's like, wow, these guys are really, really, you know, focusing on these kinds of areas for risk and to really help provide guidance. So again, this code might be the best for those particular aspects, but maybe it's not as good for some other areas where another code might be stronger. Next slide, please. The last code was, again, the one that's still in draft, and this code started after a CDC workshop in 2005, which was really the result of some recreational water illness outbreaks. So some places where pools, spas, or spray pads weren't being properly maintained, and people got sick or injured. And it's really this issue of if the code isn't strong enough, if the codes aren't enforced, if the standards don't do their job, then bad things can happen. So from this code meeting, this CDC-sponsored workshop, there was an idea to develop a model code that would really try to be very conservative and protective, but it's not going to be a law. It was going to be a model code that anyone could just pick up and choose to adopt at their state or local health department level. And the Model Aquatic Health Code would be updated after it was created. So it wasn't going to be a law like the Virginia Graham-Baker Act, and anyone who's in this industry knows all about that. So it wasn't going to be a top-down mandate. It was going to be, hey, here's a great set of requirements for you to consider and incorporate. But again, it's not an act of law. It doesn't have the force of law behind it. Next slide, please. So the Model Aquatic Health Code has 12 different modules. You can see those at this hyperlink. They were at some stage of development, whether it was draft or the drafts are done, but they have not all been stitched together. And the hope or thought from CDC is that could happen by late 2013. But also the intent for this code is that once it's issued, it will be regularly reviewed and revised. Next slide, please. So here's just an overview of some of the different modules, if you will, for the code. And you can see they actually address some really detailed aspects about contamination, hygiene of the facilities, ventilation, and air quality. Okay, ventilation, that's common. Operator training, that's not in some of the other codes. Lifeguard or bather supervision, some guidance there for actual operational aspects. And then, of course, from a link to NSF, requirements for the equipment, whether it's the circulation, filtration, monitoring, and testing, and so you have all the stuff there to be successful at that facility. But then there's the issue of just because you have good equipment doesn't mean you're going to have a safe facility. Obviously, there's the key of training the staff and having competent staff available to run it. Pool and spas are really like little water treatment facilities. Next slide, please. So again, we talked about code here, but there's the correlation between the code and the standard, as I've touched on. But the code is typically the law or the statute that's required and enforced, and it will reference standards. The codes or laws tend to move a little slowly. They don't have a high level of detail about the products, so that's where you kind of have the handoff from the code to the standard. And typically in the codes, you'll see this reference to a product or a material standard, such as, when product X is used, it shall comply with standard Y. So that type of language is typically in a code, and that's kind of the smart balance so that you don't try to load up everything in one document. You'd never get it all done. You try to reference, where appropriate, other documents. So to that end, the standards typically provide the rules and guidance for product evaluation. What types of products, materials are covered in the scope, what types of evaluations or tests are done, what are the test method details, and what types of ratings are there for pass and fail, determination, marking, instruction requirements, and so forth. Next, please. So that kind of leads us to the NSF Recreational Water Program and where it all kind of starts to fit together. Again, just kind of gave a little background on our company, the work that we've done, also talked about codes, and just kind of getting now into standards. So within NSF's Recreational Water Program, yes, we use that program to provide the testing services, conformity assessment audits, product certification. It's in that capacity that NSF works with all these different industry groups and has these different types of programs. And one of those programs being, the pool and spa or recreational water program. And through that, we use NSF Standard 50 as the key or the major standard, but others as well from US EPA, ASME, ASTM, APSP, yada, yada, yada. But the idea is that through incorporation of all these different references and standards, that it helps companies evidence compliance with codes. Next, please. Well, why was Standard 50 created, and what the heck is it? Well, Standard 50 is a standard that covers a number of different product types, but let's take a step back in time. In this case, the 1950s. Think of big fins on cars and not shark fins in the water. But in this case, when you don't have rules that can create the opportunity for chaos and risk, what we really had was a lack of infrastructure for the industry, and the industry was going through an explosion after World War II, and you know, in a positive.
Hey, Rich, you there? Oh.
Hello, did I mute out there?
Yeah, go ahead. We lost you for a minute, but
Rudimentary codes in some states, and there were not standards for the product types. And that lack of infrastructure for the buyers creates risk, also for the engineers, builders, and others. So when you don't have criteria to assess functionality, it's a little bit like the wild, wild west, and it's really a buyer beware market. Also, when there's no trustworthy source of the performance and claim verification, well, then if there's no product criteria and there's no product testing and certification requirements, there's no real protections in place to assure the buyers or users of a certain level of quality, and then things can easily be manipulated. So again, there was excessive risk for product use and facility operation, and that unpredictability and risk was passed on to the public. And the industry, really the public health industry and the trade association, realized they had a problem and they needed to address it before things got out of control. And at that time, in 1959, both the American Public Health Association, state public health officials, and a few other engineering groups, as well as the Pool and Spot Trade Association, all asked NSF to create standards for this industry. Next, please. So, you know, if you're choosing a product, there's certain things you want to verify, that the materials are safe, that the products are durable and appropriate for the end use, that there's been some evidence of the performance testing, you know, things like burst safety, output, disinfection, efficacy, what have you. That there's installation guidelines that are provided, that there's use instructions that are readily available, that there's appropriate marking on the product, you know, so you know how to use it properly, because again, you're essentially setting up a small water treatment facility. And in this case, NSF Standard 50 really sets those requirements, meets those needs for a variety of different product types. Next slide, please. So just to get a little bit more of a kind of overview on Standard 50, it's this broad standard that covers a number of different product types, and that's really what makes it kind of unique in the world, that there is nothing else out there anywhere that has comprehensive requirements for a whole host of products. And in fact, the reason for that is originally in the 1960s when NSF first started writing these standards, is there was an individual standard for each product type: sand filter, pre-coat filter, cartridge filter, pump. Those are all separate standards, but in the 1970s, those were all linked together to form one, you know, kind of super standard or umbrella standard that had these detailed requirements for different product types. The other thing is that it's a voluntary and consensus standard, so we have participation from a broad array of backgrounds and personnel. Obviously, you know, NSF's involved, but we serve more as the secretariat for it and really help to put together the expertise of these other individuals from the industry and form this equal balanced voting membership between public health regulatory, the manufacturers, the users of the product. So the NSF standards in general are dynamic, but especially Standard 50 because it has so many different product types in it. So it continues to expand and grow as other products are used in the industry, as technologies change, as knowledge is gained, then the standard is modified to address those issues. Next, please. So just as kind of a visual to kind of help bring it all together, when you've got this widespread input, it can be challenging to manage, of course, but through that input you get a document that can be acceptable to all parties, because really what you've tried to do is on the front end invite in this participation from the stakeholders of, product manufacturers. Obviously they know a lot about their widgets, and then you've got the people on the other end, let's say the governmental officials, public health officials. They're concerned about protecting the public, of course. And then there's all the users of the product, the facility operators, the people that run the pools. There's the people that are distributing the products, the people that go out and do the service at these pools and spas or water parks. And so when you bring all these perspectives together, it helps to get a better final product as far as the standard and the criteria. Next, please. So the kind of overview on Standard 50 gets into this idea of the purpose and the scope. Well, I'll talk about the scope first. The scope is quite broad. It's really just covering all these materials, components, products, what have you, that are used in either residential or public pool, spa, water park, theme park, spray pad, water park type operations. So again, it's really covering virtually anything that's used at the pool, spa, or water park. And then Standard 50 also goes into having certain categories of evaluation criteria. Typically those for material health, safety, corrosion, chemical resistance, design and construction requirements, all sorts of performance, chemical or microbiological testing criteria, and then other details as it relates to marking of the product, the instructions, replacement parts, and then appropriate sizing of the equipment for the particular water body you're treating. Next, please. So I'm kind of hitting that theme again of the tie-in between the different entities and the standards. So you have the criteria, but you want that criteria to be worked on, if you will, by this equal balanced voting membership. So what there currently is I think 11 different manufacturer votes, 11 different public health official votes, and CDC has a vote, and then various state officials. And then you have others, more the service companies, the builder, designer personnel, as well as the test labs. So between all three of those, you're really well representing the needs and interests of the industry for the development of the criteria. Next, please. So this slide just gives you the first kind of overview of some of the product types that are covered under Standard 50. It really either has detailed requirements within the standard, or it refers to another external standard. So I kind of refer to NSF Standard 50 as an umbrella standard that covers everything. In the case here, I put some things in red, and the red items are typically those that would incorporate electrical componentry, need some type of an electrical safety evaluation. But the ones in blue typically do not. Some filters do. Obviously, some valves are electrically actuated. And there's other details like that. But those are the major classes, if you will. Next slide, please. On this slide, you see a lot more red. Well, that's because a lot of those things can get plugged into the wall. Some are actually direct hardwire, of course. But the issue is that these other products are also covered by Standard 50, whether it's the chemical feed pumps, the flow-through erosion feeders, which are sometimes pump activated and have other electronic controls, ozone generation systems, but it's not just ozone generation, it's really the quality of the mixing system to make sure you have good contact time. UV systems, again, it's not just a lamp, so the lamp and the reactor design to affect performance. And then chlorination systems, whether they're inline or brine and batch type, the ion generators, copper and silver, and then combination systems for advanced oxidation potential, and then other kind of mechanical processes, whether it's a strainer before a pump, whether it's a suction fitting, again, a critical safety product, but typically never has any electrical evaluation because it's normally just a plastic plate with perforations in it. Then some of the other products like the SVRS safety vacuum release systems, there's ASME and ASTM standards that NSF uses when we test those. There's pool and spa covers. We use an ASTM standard for those. Let's see here. Sorry, I had my screen go out. Then the pool alarms covered by ASTM 2208. So the next thing we want to do is just going to go over this concept of the certification process. Well, what is certification as it compares to testing? Testing, or a test, is a one-time event. Certification is a process of being a little bit more thorough than just conducting a test. Obviously, there's a review of materials, and that typically happens after company applies for certification. You get into the details of their product to determine what is appropriate for testing or what requires testing. Obviously, there's a manufacturing facility audit. Then there's the compilation of the results of that testing. And then if the product passed the testing to serve as representation for the other products that the company produces, that company may be eligible for certification. So certification, again, is not just a one-time event. It's more like an ongoing assurance, a conformity assessment, so that there's annual inspections and then some period of reevaluation or retesting as well. Next slide, please. So just to kind of get into a little bit more detail and flesh that out, during the application process, it's really almost a discussion between the company and NSF about, what types of products are you interested in having certified. Then we get to understand those products a little better, establish the required work to certify those products, develop the cost estimate, and then if the company moves forward, they'll typically submit more detailed information as it relates to design drawings, claims, things of that nature, details of their suppliers and parts list. Then there's also the inspection, because if you're going to certify a product, you have to make sure that the company is really using the suppliers they say they're using, and they're not just willy-nilly making changes in design or claims or suppliers and materials. Obviously, if you do that, you could get different performance and different results. So you're really trying to document what is occurring and then perform an evaluation and determination of the appropriate testing of the products to represent the family of products. And that might be for performance, might be for chemical aspects, microbiological aspects. But besides the testing, there's also evaluation criteria. And then all of that is brought together in what we call the documentation report. And that's the information that kind of is the proof of everything that was done. It's evaluation of a certain range of, or a family of products, and the critical parts list for those, the NSF testing report, the NSF audit report, put all that together, and if it's successful, the company is able to become NSF certified, and then go in for annual follow-up audits. Next, please. So here's some examples of different product types. Let's take the pumps first. Next slide.
Hey, Rich, you got 2 minutes to finish up, so if you could just breeze through the last bit here quickly. Thank you.
Okay, you bet. Yeah, so this is just a basic overview of some of the pump criteria, traditional type pump burst safety curve tests, things of that nature. Next slide, please. Next one after this is dealing with chemical generators. Again, a lot of these electrically driven products are covered in this aspect, and what I'll do is just give you an example on the next slide of some of the criteria. I'm sorry, the slide after this, just a visual of automatic controllers. But you can kind of see with the chemical feed systems, there's a number of different pressure tests and erosion criteria and chemical output tests, and assessing the accuracy and repeatability, certain protections, as well as marking requirements. Next slide, please. Related to the chemical feeders, there's also the control systems. In this case, you've got all the other tests that are conducted on automatic controllers. Next slide, please. So there's examples of these other supplemental products, such as UV, ozone, and other products. And the next slide kind of gives you a visual or a graphic on some of the tests. So it's, again, traditional material and design criteria on the left side, and on the right side you see this overview of all of the evaluation criteria for ultraviolet light treatment systems. Some of that is evaluation-based, some of it's actual performance testing, life testing, disinfection efficacy, things of that nature. Next, please. So if you're trying to find listed products, you would just go to that hyperlink on the top, and you could search under all these product types. And on the next slide, it'll kind of help bring it into easy to grab. On the left side here at the 9 o'clock position, you can see us search products. So next slide will show you what that looks like. Let's find the search engine. In the middle of the page here, you can search by trade name, product type, where the facility is located, and also manufacturer name. So next slide, please. This just kind of gives you an example of a drop-down list, so it makes it really easy to find exactly what you're looking for by product type. Next slide, please. So just to summarize, there's really this link between the standards, the codes, and then really how people evidence compliance with these requirements is through certification. And those certification criteria address the material safety, durability, performance, marking, and other issues. and you can utilize the NSF certification as your key to showing code compliance. You can use the NSF website to find certified products to help evidence compliance with the model codes or state and local plumbing codes. And last slide, please. So it's just contact information if you have any follow-up questions. Thank you.
Okay, my name is Lauren Foster. I'm one of the senior project engineers here at Med Labs. Today I want to talk about the product safety aspects of equipment used in pools and spas and hydro massage equipment. Some of the things I'm going to cover are a little more in detail than things that Richard talked about, and I hope this will be a great presentation. If you're not familiar with Met Laboratories, let me tell you a few things about us. We've been doing product safety for over 50 years. We're approved to investigate over 200 different types of products, including the ones we'll be talking about today. Today I want to cover several topics about how we investigate a product for safety and some of the things you should be mindful of when you're designing a product that needs safety certification. The first thing you always want to do when you're designing your product for safety is to get a current copy of the standard that applies to your product. This way you can see exactly what we see and know why we are testing and evaluating your product in a certain way. This will also help you in the design phase, as you will know what you should and should not include in your product. There are hundreds of standards for different products on the market, unlike the number 50 the NSF uses. The first ones I'll cover today are for electrical products used around water. The first one is UL 1081 for pumps and chlorinators. The next one is UL 1261 for electric water heaters. Then there's UL 1563 for spas and equipment with hot tubs, pools, and spas. And next there's UL 1795 for hydro massage bathtubs. There are also 3 Canadian standards which are similar to the U.S. standards but have slightly different requirements. I'll be showing you those later. The standards are number 108 for liquid pumps, number 218.2 for hydro massage bathtubs, and number 2118.1 for spas and hot tubs. The primary hazards associated with this type of equipment are electric shock, temperature, and fire. There are also some mechanical hazards to consider. Let's talk about how serious electric shock is with water handling equipment. Designing to lower the risk of electric shock is critical with water-based electrical equipment because of how easily water conducts current. Not only can electrocution be fatal, but there's also the risk that a shocked person will become immobilized or drown. So when designing to protect against electric shock, you should be covering or surrounding all live parts with insulation, such as water insulation, terminal blocks, and enclosures. If an enclosure is made of metal or has metal parts that could touch a live part, they also need to be electrically bonded together and tied to ground. You will also need to pass all water through a bonded metal leakage current collector. We'll talk more about this later. Now let's talk about how serious excess temperature is in terms of water. The maximum temperature of spa and pool water must be limited to 104 degrees Fahrenheit. This is because the human body can only deal with so much heat before succumbing to hyperthermia, which can lead to fetal damage or even drowning. Now you can't necessarily prevent a person from using drugs or alcohol around a pool or spa, but you can limit the water to a safe limit. Now there are 2 components that should be installed in any product associated with heated water. One is a thermostat that turns the heater off depending on the temperature, and the next is a thermal cutout which turns off all the power if the thermostat fails. One of the tests that we do is make sure that this redundant protection works by disconnecting the thermostat or the thermal cutout and seeing what happens. The last major hazard to cover is a fire hazard, and that's generally caused by an electrical fault in the system, but can also be caused if there's no water flow, which is a condition we test for. If we can't make sure that a fire doesn't happen, we ensure that the fire has nothing to burn or nowhere to go. So one of the aspects of designing equipment is choosing the components. Usually you know what voltage you can expect the system to run on, and there will be components that have to be rated for that voltage. In terms of current, some equipment like your pumps and heaters and motors will act as a load, and other equipment such as your fuses, circuit breakers, and terminal blocks need to be able to bear that load. Your pumps and piping must be able to withstand the pressure they'll see. Your cords and enclosures need to be water resistant. And on top of that, your components need to have safety certification to ensure that they'll meet safety requirements on their own. And I'm going to whip through these next couple of slides just to show you that your components have many individual standards, as I said. This is not like the NSF Standard 50. It's done by a different model to be very specific for product safety of individual components. Now, here are some examples of components you may need to use in your system and the types of ratings you need to be concerned about. All of these basically need to be controlled by voltage and current, which means that if you have a circuit breaker or ground fault protection, if you're going to use a 240-volt rating, then those components also need to be rated for that voltage and current. If you have a 40-amp system, you have to have a 40-amp breaker. Next, these components have to be able to withstand temperature or water that they'll see. You may have a circuit board that has to withstand a certain temperature. Your power supply cords have to be water resistant. Your heating elements also have to be rated for a specific temperature. Now, I've put together a list of the different types of components and the standards they have to comply to. These standards ensure that the equipment doesn't catch fire, doesn't explode, doesn't break. It's a long list. Remember, I said there are hundreds of standards. A very long list. And here's the end of the list. Now, there are several different certifying bodies that investigate components to the standards I've listed. You don't necessarily have to go to UL, which is considered the primary agency that investigates components. But it's important to keep in mind that when these components are tested, there's no way to know what type of product they're going to go into. So there's a list of features that the end product, which is your product, must comply to, and these are called conditions of acceptability. You should take a look at them because we're going to ask for them. Now, I will freely admit that certified components cost more, but there are hazards associated with not using certified components that you don't want to risk. We can investigate a component to its component standard in addition to investigating your actual final product. But remember that it's in addition to, so there's an extra cost, and we will inspect that component every year, also at a cost. And the product may fail to comply. So we don't recommend that you use uncertified components. Now, I want to spend a minute talking about the enclosure of an electrical product because it provides mechanical, electrical, and fire protection for that product. It's very important that you select the material carefully and select a specific thickness so that it can stand impact, not corrode, not catch fire. There are also some special requirements for water-related electrical products. For example, spas cannot be metal, heaters must be metal, cast and sheet metal have minimum thicknesses according to each standard, and plastics have minimum thicknesses to prevent them from catching fire. If you decide to use a metal enclosure, you need to make sure that all the live wires are a certain distance away from that enclosure. If you choose a plastic material, you need to be sure that it has necessary properties to prevent electrical conduction, prevent or contain a fire, and withstand the temperature that it will see. One way to handle the heat that's generated in a piece of equipment is to provide ventilation openings. However, you need to keep these to a minimum and keep them small. The bigger they are, the further distance the live parts need to be away from them. For example, if you have a small 3/4 inch opening, then your live wires have to be at least 4 inches away. If you have a large 2.5-inch opening, your live wires have to be at least 17 inches away. Again, it's very important that you keep your ventilation holes small. I want to take a few minutes to talk about grounding and bonding. Grounding is your connection to the earth line, and bonding is your connection between all of the metal of the system that's not insulated to that line and to each other. Bonding is absolutely critical in preventing electric shock because it prevents the metal enclosure from becoming live if something becomes loose inside of your equipment. Now please take a minute to read this. A ground fault occurs when electricity travels outside an intended path and tries to get to the ground by the shortest route. If you touch something that's electrically live while you are grounded, touching the ground or something resting on ground like the ladder, if it's electrically live, your body becomes electricity's shortest route to ground. You can also become part of electricity's path to ground if you touch water that touches something that's electrically live. In either case, you can be hurt or killed. Please read this too. The critical point is that your product is permanently connected. So your electrician will have connected all of the metal to a grid. If it's cord connected, you have to require through your instructions that the customer ground the plug. Again, we have equal potential bonding to equalize the potential around the entire body of water so that the person doesn't create a circuit between areas of differing potential, which could result in getting shocked. That's what we're concerned about, is making sure that a person doesn't get shocked. So the grounding, in essence, is what the customer does when the unit is plugged or wired in to make a connection to the plug or earth ground. But the bonding is what you design to make sure that every piece of metal is interconnected. Notice that the gauge of the wire is huge. The gauge for U.S. equipment is 8 AWG. The gauge for Canada is 6 gauge. That's how important bonding is to electrical products around water. Now, a couple of last things about bonding. A ground fault circuit interrupter is absolutely necessary with most electrical products associated with water. I've got a list of some of those pieces of equipment here. With hydromassage bathtubs, unless it's permanently connected, it's expected that a GFCI will be provided externally. I also want to talk about the leakage current collector. This is another component of water equipment that is absolutely necessary. The leakage current collector is a piece of copper or brass tubing or plastic tubing with a corrosion-resistant lug inside of it that all water passes through to provide a path to ground for all of the water that has come in contact with an electrical appliance. It gets installed in all of your water inlets, all of your water outlets. Again, it will be bonded to about 6 gauge wire to the main service ground. So as I said, a leakage current collector is very important in the design of your equipment, and it's absolutely necessary for water heaters, spas and hot tubs, and bathtubs with electrical appliances. Now, part of your design will include what's called electrical spacing. That's the separation between your live parts, your live and neutral, your live and ground. There needs to be a certain distance between these components. If you have a field wiring terminal, the spacing requirements tend to be greater because of the possibilities of loose wires. And this is one of the places where having a certified component like a terminal block comes in handy because the spacings are already certified. However, if you're designing a circuit board, it's critical that the board be laid out with proper spacings, and this is one of the things that we'll be measuring when we inspect your equipment. In addition to looking over your product, which we call our construction review, we're also going to put your product through a rigorous battery of tests. The tests that I've listed here are done on any water-based electrical product. We're going to make sure that the current rating is accurate since it determines the size of the wiring and the electrical breakers. We're going to check the surface and the water temperatures. We're going to check for excess current. We will check the electrical separation between live circuits and ground. We'll check bonding continuity to ground, and we will do fault testing or abnormals. Every aspect of the system should have redundant fault protection so that if one thing fails, there is something else to back it up. Here are some of the abnormal conditions that we're going to look at. We only do one fault at a time, and we see what happens. We want to make sure that we don't have excess heat, fire, or shock. Now, in each standard, there are special tests that will be done on the equipment to make sure it's safe. For example, if we have swimming pool pumps, filters, chlorinators, we're going to look at water exposure. We're going to look at excess electrolytes in the chlorinator. We're going to look at the possibility of flooding. We're going to look at some UV exposure if you have a polymer exposure. We also have some tests that need to get done on water heaters. Notice the number of cycles that are required for switches. This is often well above what is required in the component standard. We may have to do 100,000 cycles if you have an automatic reset, 5,000 cycles for a manual reset. We're also going to be aging your gaskets and seals to make sure that over time we don't have a problem with water coming into your system. Now, with the electric spas, we have a water temperature test. You can't go over 40 C no matter what kind of abnormal condition you have. We also have a lot of tests due to the fact that the product may be outdoors. Now here with hydromassage tubs, we have a lot of the same tests for spas. Some are different. Again, we've got our gasket and aging tests. We've got our switching overload tests. But we've also got some leakage current tests and some heater tests specifically for the hydromassage tubs. Changing subjects, I want to talk about markings. This is something else that we'll be investigating. All products must have marking, and we need to examine them and test them for durability. For example, if you have a tag for pumps and filters, it has to have this information on it. If you have a spa, again, you have some very specific marking requirements. If you have a Canadian product, notice that you have to have your ground fault circuit interrupter tested before each use of the spa. Please also notice that if you're going to ship a product to Canada, your markings need to be both in English and French. We're also going to review your installation instructions. We need to make sure that the proper safety precautions are there. There's a little bit more. So we're going to investigate your product, and for the first time, we're going to be looking at the things you need to do for your design. But there's an additional step. This is what we call surveillance. In addition to our initial review of the product, we're going to look at your factory the first time you make it. We're then going to look at your factory twice a year, make sure that the product is the same. We'll also require that you do some basic tests on every product that you make. And that's the end of my presentation, and now we'll go to Rick Cooper.
Thank you, Lauren. Very informative presentations given by Rich Martin of NSF and Lauren Foster of MET Labs. We're getting down to the wire here, and I'd like to let everyone know not to worry. My presentation, or my portion of this presentation, is far shorter and honestly less informative than the previous two, so this should go pretty quick. Again, I'm Rick Cooper. I'm the director of the Product Safety Laboratory, and I just wanted to take a couple of minutes to briefly explain the MET-NSF process, basically how we work together. Next slide. So working with MET, and NSF is going to assure that your products comply with applicable safety standards, including all aspects of recreational water applications, as well as the basic electrical hazards and fire hazards, temperature hazards that Lauren covered. And there's no need for me to repeat the types of products here. Both Rich and Lauren have done a very good job at giving you an idea of what types of products are covered by our two programs. Next. So as Rich has explained, they're going to evaluate, test, and ultimately certify products for compliance with sanitation and water recreational equipment requirements. And their focus is going to be performance and safety that's related to reliability of such products. MET's going to evaluate, test, and certify these products for essentially the other safety hazards with the electrical shock and fire and temperature hazards that are associated with most electrical products that must be mitigated in order to comply with safety standards. Next. So I've expanded on the list of hazards that Lauren mentioned. This is a fairly comprehensive list of hazards that most any electrical safety standard will deal with. There's risk of electric shock, which is essentially electrocution, the access to hazardous voltages, and the resultant current that may flow through the human body. There's electrical energy hazards, a little different than electric shock. This is high current discharges. Could be something like a capacitor storing a charge and being accessed. It could also be the energy from a 12-volt car battery. 12 volts may be considered safe, accessible, but not if you drop a wrench across the terminals. Risk of fire, mechanical hazards, moving parts, sharp edges, heat hazards. I think Lauren covered those pretty well. Radiation hazards, not really sure if this is going to be much of an issue in these types of products, but you're usually looking at radio frequency radiation or laser light radiation hazards. Chemical hazards, maybe some of that that have to be addressed to some extent, but it's primarily going to be to make sure that any potentially hazardous chemicals are simply handled properly and the users are given sufficient means to properly handle those chemicals in your products. Next slide. So the process is quite simple. You can contact either MET or NSF. We each know when to recommend the services of the other. We can each counsel you on what you probably need to do to market your product. And together we're going to cooperate and provide to you the most cost-effective and efficient method to get your water recreational product to the market. And I believe that wraps up my presentation. Next slide. Yes, it does. Okay. Well, okay. Thank you.
Yeah, thank you, Rick. That concludes the presentation portion of the webinar. A copy of this webinar will be available on metlabs.com, and we will send a follow-up email with a link to it. Now, we're just about out of time, but we do have, we're going to take time to answer just a couple questions. If you have a question, please type it in the questions area of your control panel. For questions we can easily address now, we will read the question aloud, then give the answer. Rich, I think you have a question.
Are you able to read that question off for me?
Hey, I don't have it in front of me. There is another question that's come in here. Perhaps either Rick or Lauren can address it. The question is, NSF 50 was reported as voluntary. Is UL and CSA safety standards compliance also voluntary? Does Rick, do you or Lauren want to answer that?
I'll go ahead and answer that. Most likely no is the answer. It's going to depend on where your products are going to be used. In the United States, the OSHA NRTL program requires that electrical products used in places of employment comply with national electrical safety standards. So if your product's going into a commercial location where there may be people getting paid to do a job, and therefore under the NRTL or under OSHA rules and regulations for workplace safety, then the electrical equipment is going to be required to be certified to appropriate safety standard. It also is going to depend on where your product is sold, or rather how it is sold in a retail environment such as a Walmart or even an online shopping network. Require that electrical products, particularly those powered from AC mains, be certified to appropriate electrical safety standards before they will stock and sell those CSA standards being the Canadian standards. So I'm going to say no, it's not voluntary. Any other questions out there, Barnaby?
I don't have any other. Rich, were you able to access that question that came in for you?
Yeah, I see there's two of them out there. One, okay, what types of organisms does NSF use in its microbiological testing? You know, for the pool and spa market, there's two traditional bacteria, gram-positive and gram-negative, Pseudomonas aeruginosa and Enterococcus faecium. Those are kind of like the ones that are responsible for what they call hot tub rash and things of that nature. So those are the common ones. And then there's other organisms, Cryptosporidium parvum, and then a surrogate for that, MS2. That's phage that's used for some of the testing as well. But those are typically used like when we're testing ultraviolet light systems or other products that are claiming to inactivate cysts. So there's some 3-log disinfection efficacy tests that we use those organisms with. And then let's see, there's another one here. Just how long does a standard 50 project take? You know, how long does it take to certify certain product types? So, well, for that, you know, depending on what kind of product type it is, it might be like 45 to 90 days. If there's no chemical resistance or life testing, when we have the chemical resistance test, that's 100 days exposure to elevated chemical concentrations. And if it's the life test, you know, certain product types require life testing. The life test is 3 different units that are undergoing use for 3,000 hours before you conduct the other traditional performance output biological disinfection efficacy tests. So the projects could range from 45 to 90 days for some of the stuff that doesn't have long-term tests, and then for the things that are long-term tests, it's more like a 5 to 9 month project. So hopefully that addresses the question all right.
Thank you, Rich and Lauren and Rick. If you have any additional unanswered questions, please contact us by phone or email. That concludes our webinar today. Thank you for joining us.